Okay, let's look at the rational expressions homework page again. Previously we did number 1. I'm going to go ahead and do number 5 on the rational expressions homework page. So we'll use that as an example. So I'm going to do, again, a deep dive into a little bit more of an explanation as to why some of this stuff works, why it cancels out, why we simplify it, what factored form looks like, and hopefully it will help with a little bit better understanding. So if we look at number 5, the problem is 4w squared minus 11w minus 3 over 16w squared minus 1 times 8w minus 2 over 9 minus w squared. Okay, so again, we're going to break this down. So whenever I have something this complex, I'm going to look at it as 4 separate things that I have to simplify. Okay, so we're going to break it into chunks. So I'm going to, I'll call this one 1, this one 2, this one 3, this one 4. Okay, just for the sake of our simplification here. So let's look at the first section here. So we're going to look at 4w squared minus 11w minus 3. So I see there that that's a trinomial. If I'm looking for a greatest common factor, I'm not seeing one. There's no number that goes into 3, 11, and 4 evenly. There's also not a variable that they all share that I could pull out of parentheses or divide everything by. Okay, so now I'm looking at, I can use the area model or the X method. So we're actually going to do both because, again, this is a little bit deeper dive. So we'll start with the X method. That one's a little bit more of a shortcut, a little bit more, I guess, challenging to conceptually understand, but it's faster for a lot of people. So when I use the X method, I am multiplying the first coefficient, so A, with my constant here, which is C. So my coefficient of my first term, coefficient of my last term, but there's no variables, so it's just a constant. So we have A times C, and so again, this is A, this is B, this is C. So A times C is 4 times negative 3, so negative 12. So we want to find 2 numbers that multiply to make negative 12. And then I want to find 2 numbers that add to whatever B is. And B in this case is negative 11. Don't forget that negative sign. It travels with that term. All right, and so now I'm seeing, okay, well, the only way to get to negative 11 is if I go with negative 12 and 1. So negative 12 times 1 multiplies to make negative 12, adds to give me negative 11. So now I'm going to write out how this is going to break down into parentheses, how this is going to be factored. So the first part is my variable. To figure out what the variable is, I look at the middle term. So it looks like I'm just going to have a W here. Then I'm going to look at what I came up with for the numbers that add or multiply to negative 12 and add to negative 11. So I'm going to go in and say, okay, negative 12, so I have W minus 12. Okay, and then I have positive 1, so W plus 1. But I'm not done yet because my first move was to multiply C by A, was to multiply by 4 to get this right here. So before I move on, I have to undo that by using an inverse operation. So the inverse operation is division. So I have to divide my last number here because I multiplied my last number by 4. I have to divide the last number in each of these by 4. Okay, this is basically just a shortcut or trick to figure out which one of the W's has a number in front of it, okay, and figure out where my 2 numbers here are going to go, okay? So I look at the 12 divided by 4 and say, okay, well, I know 12 divided by 4 is 3, so that simplifies to 3. And I know 4 doesn't go into 1 evenly, so I'm going to bring the 4 in front of my W. So what I end up with in the end is W minus 3 times 4W plus 1. So I'm going to rewrite this. So I did my first one, W minus 3 times 4W plus 1. Okay, first corner is taken care of. Let me show you the area model really quickly though, just so that you have an idea of how that might look. So let's go back to our original. So we have 4W squared. So my highest degree term goes here. Okay, so it's W to the second power. Okay, that means it's second degree. Okay, and then I have my constant or my final term here in the bottom right corner. So my goal is to get numbers where they need to be, numbers and variables where they need to be, so that these two boxes add up to negative 11. So I'm thinking to myself, okay, what multiplies to make negative 3? Well, I know it's probably going to be negative 3 and 1. And you might be asking, how do I know it's the 3 is going to be negative? Well, the 3 is going to be negative because I'm looking at my middle term and I'm like, okay, I need to get to negative 11. That's got to be a pretty big number. So a lot of times, the bigger number is going to be negative. Not always, but a lot of times. So it's a good place to start. So maybe you'll do some guess and check, and you might be wrong the first time, and that's okay. You'll just switch the signs. So 1 and negative 3. Okay, and then to get to negative 11, well, I know that 4 times 3 is negative 12, so what if I put 4W here to get negative 12W, and then I just put my other W here, because I know 4W times W is 4W squared. W times 1 is just 1W. If I combine these middles here, then I've got a negative 11W. So this all adds up. All my boxes add up to make this right here. So that means that my factors on the outside are W minus 3 and 4W plus 1. And the way that we know this works is that when I multiply this back out, 4W times W gives me 4W squared. 4W times negative 3 is negative 12W. W times 1 is 1W. Negative 3 times 1 is negative 3. If I add all these together, I end up with what I started with. Okay, so that's a way to check to see if we're right. Okay, so that's the first part. So again, this takes a while. Okay, and remember, these are just my number corners here. It takes a little while, but in the end, it should simplify it quite a bit. So let's look at the second corner. So 16W squared minus 1. I'm looking at that and I'm like, okay, it's squared and there's a minus sign. I'm going to use difference of squares. So again, difference of squares, kind of like we talked about in the last problem. I'm going to take the square root of the first term minus the square root of just the second term without the negative sign. Okay, we're going to ignore that. Okay, so what I get in the end is something minus something and something plus something. It's going to be the same thing. So I'm trying to find the square root of 16W squared to get the first term. And then I want the square root of 1 to get the second term. Okay? So square root of 16W squared, what I'm going to do is break that up into the square root of 16 and then the square root of W squared. So I know the square root of 16 is 4. The square root of W squared is just W. So the first term here is 4W And then the square root of 1 is just 1 minus 1 plus 1. So that is now in its simplest form. There's nothing else I can do. So 4w minus 1, 4w plus 1. Okay, got my second box done. Let's look at box number 3, or corner number 3. 8w minus 2. So I'm looking at that, nothing squared. The only thing I see that they have in common is that I can divide both of these by 2. So I'm going to use the greatest common factor factoring method, and I'm going to say, okay, if I divide everything by 2, I'll take a 2 outside of the parentheses. Oh, do you know what? That should work. Okay, I almost thought 4 went in. It doesn't. Never mind. So 4w, and then, so 8w divided by 2 is 4w, minus 2 divided by 2 is just 1. So I have 2 times 4w minus 1. If I multiplied this back out, I would end up with what I started with. So we know we did it right, because if I multiplied this back out, I would end up where I started. But by factoring it, you're going to see we're going to be able to make some 1s and cancel some stuff out. So 2 times 4w minus 1. Okay, now we're going to look at the final corner. So we got number 4 here. So I'll pull it down here. So I have 9 minus w squared. Well, I see that I have squared, there's 2 terms, and I'm thinking, okay, there's a minus sign, so I could probably use difference of squares. I know that I can take the square root of 9. I know that I can take the square root of w squared, so this should work out really nicely. So we're going to do exactly what we did over here, and we're going to take the square root of 9, and we're going to take the square root of w squared, and we'll end up with something minus something, something plus something. And remember, the first term's going to be the same, the second one's also going to be the same. So the first one is square root of 9. So square root of 9 is 3, so 3 and 3. Square root of w squared is w, so w and w. Cool. Okay, so that's it. That's as far as I can go there. So 3 minus w. Oh no, that's a 3. 3 minus w, and I'll rewrite this in a sec here. And 3 plus w. Okay, so I'm going to go ahead and rewrite this down at the bottom so I have a little more space to work with. So I have w minus 3, 4w plus 1, times 2 times 4w minus 1 over 4w minus 1, 4w plus 1 over 3 minus w and 3 plus w. This is where the fun happens. So I can, again, when I have factors that are being multiplied, it doesn't matter which order I write them in, as long as I know that I'm multiplying. So I'm not taking out any of the parentheses or anything. I'm just moving around parentheses if I need to. But right now, I don't need to. So I'm going to look for things that match, because if I'm multiplying fractions, remember, this is just multiplying straight across. Everything's being multiplied. So I could literally rewrite this as w minus 3 times 4w plus 1 times 2 times 4w minus 1 all over 4w minus 1 times 4w plus 1 times 3 minus w times 3 plus w. And now I'm going to look for things that match on top and bottom, because whenever something is divided by itself, it makes a 1. So 4w plus 1 over 4w plus 1 makes 1. So, and multiplying by 1 doesn't change the value. Same thing here. Even though this is far away, it's all being multiplied. So I can cancel out 4w minus 1. 4w minus 1. Then here's where it's a little funky. So I'm going to rewrite this. So I have 2 times, because I saw the 2 up here, 2 times w minus 3 over 3 minus w times 3 plus w. What happens here, w minus 3 and 3 minus w, those cancel to make -1. And I'm going to show you why that works really quickly here. So w minus 3 and then 3 minus w. Okay, w minus 3 and then 3 minus w. Again, I'm writing 3s. Why am I doing that? Okay, so we can actually make 3 minus w into w minus 3 by dividing by -1. So if I use distributive property and I say, okay, if I divide everything on the bottom by -1, so I still have w minus 3. Then I have negative, and then outside parentheses, -3 plus w. Well, -3 plus w and w minus 3 are the exact same thing. So these actually become a 1 because w minus 3, -3 plus w, again, exactly the same. So it's w minus 3 over w minus 3. So it actually becomes -1. So I can go ahead, cancel those out, and then turn my expression negative. So this becomes -2 over 3 plus w. So all that hot mess up top simplified down to -2 over 3 plus w.